वालेकुम, वेलकम टू माय यूट्यूब चैनल। आज हम पढ़ेंगे इम्प्रूव परफॉर्मेंस। द केस फॉर द इम्प्रूव परफॉर्मेंस ऑफ डिस्ट्रीब्यूटेड DBMS is typically made based on 2 points. First, a distributed DBMS fragments the conceptual database, enabling data to be stored in close proximity to its point of use, also called data localization. This has 2 potential advantages. Since each site handles only a portion of database, contention for CPU and I/O services is not as server as for centralized database. Localization reduces remote access delay that are usually involved in wide area network. For example, the minimum round trip message propagation delay in satellite based system is about 1 second. Most distributed DBMS are structured to gain maximum benefit from data localization. Full benefit of reduced contention and reduced communication overhead can be obtained only by a proper fragmentation and distribution of the database. This point relates to the overhead of distributed computing. If the data have to reside at remote sites and one has to access it by remote communication, the argument is that it is better in these circumstances to distribute the data management functionally to where the data are located rather than moving large amount of data. This has lately become a topic of contention. Some argue that with the widespread use of high-speed, high-capacity network, distributing data and data management function no longer make sense, and that is may be much simpler to store data at a central site and access it over high-speed network. This argument, while appealing, misses the point of distributed database. First of all, in most of today's application, data are distributed. What may be open for database is how and where we process it. Second and more important point is that this argument does not distinguish between bandwidth, the capacity of computer links, and latency, how long it takes for data to be transmitted. Latency is inherent in the distributed environment, and there are physical limits to how fast we can send data over computer networks as indicated above. For example, satellite link take about over computer networks as indicated above. For example, satellite link take about half a second to transmit data between 2 ground stations. This is a function of the distance of the satellite from the earth, and there is nothing that we can do to improve their performance. For some application, this might constitute an unacceptable delay. The second case point is that the inherent parallelism of distributed system may be exploited for inter-query and intra-query parallelism. Inter-query parallelism results from the ability to execute multiple queries at the same time, while intra-query parallelism is achieved by breaking a single query into a number of subsequent, each of which is executed at a different site, accessing in different part of the distributed database. If the user access to the distributed database consisted only of querying read-only access, then provision of inter-query and intra-query parallelism would imply that as much of the database as possible should be replicated. However, since most database accesses are not read-only, the mixing of read and update operation requires the implementation of elaborate concurrency control and commit protocols. Easier system expansion. In a distributed environment, it is much easier to accommodate increasing database sizes. Major system overhaul are seldom necessary. Expansion can usually be handled by adding processing and storage power to the network. Obviously, it may not be possible to obtain a linear increase in power, since these also depends on overhead of distribution. However, significant improvement are still possible. वीडियो अच्छा लगे तो लाइक कीजिए, शेयर कीजिए, सब्सक्राइब कीजिए.